All right, today we are not just doing math problems. We're basically becoming detectives. We're going to build a toolkit for cracking one of the most common puzzles you'll ever find in algebra.
So think about it like this. What if you have two different pieces of information, right? Two totally separate clues, but you know they're connected. How do you find that one single truth that makes both of them work? Well, that's the big question we're tackling today.
So yeah, we're calling this the two-clue problem because that's really what it boils down to. You're given a puzzle in two parts, and it's our job to find the one solution that brings the whole thing together.
Now, in the math world, this kind of puzzle has a formal name, a system of equations. It sounds kind of fancy, but it just means you have a set of two or more equations that are related. And if you were to graph these equations as lines, the solution is just that one single point where they cross.
So that's our goal, plain and simple. We are on the hunt for one specific xy coordinate, one x value and one y value that is like the magic key that unlocks both equations at the same time. It's the one answer that solves the whole mystery.
Okay, let's start filling up our toolkit. The very first tool we've got is the substitution method. I like to call it the clever swap. This is your best friend when one of the equations has kind of done some of the heavy lifting for you already by telling you what one variable is. It's all about a strategic swap.
The whole process is really just a simple four-step game plan. First, you get one variable all by itself. Then, you take what it's equal to and swap it into the other equation. That lets you solve for the first variable, and once you have that piece of the puzzle, finding the second is super easy. Let's actually see how it works.
So here are our two clues. Now check this out. Equation 2 has already done step 1 for us. It's literally telling us that y is the same thing as 2x minus 3. That's the piece of info we're about to swap in.
So we just take that 2x minus 3 and plug it right in where the y was in the first equation. And just like that, we have an equation with only one unknown, just x. From here, it's simple algebra. We combine the 3x and the 2x to get 5x, do a quick calculation, and bam! We've got our first part of the solution, x equals 1.
But hold on, we're not quite done. We have to find y. So we take that new knowledge, that x is 1, and plug it back into our second equation. It's just the easier one to use. So 2 times 1 is 2, and 2 minus 3 is negative 1. And there it is. The full coordinate, the single point where these lines meet, is 1, negative 1.
All right, on to our next tool. This one is called the elimination method, or as I like to think of it, combine and conquer. This method is awesome, especially when both equations are all lined up and substitution just looks like it's going to be a mess. The whole idea is to add the two equations together in a way that makes one of the variables just disappear.
So here's how you do it. You line everything up nice and neat. Then, you multiply the equations by just the right numbers to make the coefficients for either x or y perfect opposites, like a positive 6 and a negative 6. When you add them up, that variable cancels out, and the rest is easy. Let's look at this one. On the left, you see our original clues. Now, to get rid of the x's, we need their numbers, the coefficients, to be opposites. So we multiply that entire top equation by 2 and the whole bottom equation by 3. And look what that does. Now we've got a positive 6x and a negative 6x, perfectly set up to be eliminated.
And now for the cool part. We literally just add the two new equations together. The 6x and the minus 6x, they just cancel each other out. Gone. We're left with this super simple equation, 7y equals 14. A quick division tells us that y must be 2.
Okay, we've got our y value, we take it and plug it back into one of the original equations. It honestly doesn't matter which one you pick. So here, we see that negative 2x plus 2 equals 2. Well, that means x has to be 0, right? And there's our final answer. The solution is the point 0, 2.
Okay, so we've got these cool new tools in our toolkit, but what are they actually for? Well, let's see how they can take a word problem that sounds confusing and turn it into a simple puzzle we can actually solve. This is where the magic really happens. So here's our next case. We're looking for two secret numbers. We've only got two clues. When you add them up, you get 36, and when you subtract one from the other, you get 4.
The very first, and maybe the most important step here, is to translate this from English into math. So let's call our two mystery numbers x and y. The first clue, their sum is 36, well that just becomes x plus y equals 36. And the second clue, their difference is 4, becomes x minus y equals 4.
And look at that, we have a perfect system of equations ready to go. And you know what's really nice about this one? The y terms are already opposites. We have a positive y and a negative y. This problem is just screaming at us to use the elimination method.
So let's just add them up. The y's cancel each other out completely. X plus x gives us 2x, and 36 plus 4 is 40. The equation 2x equals 40 is about as easy as it gets. X must be 20. Then we just pop that 20 back into the first equation, and you can see right away that y has to be 16.
And there we have it. The two numbers are 20 and 16. But, we should always do a quick check to be sure. Is there some 36? Yep, 20 plus 16 is 36. Is there difference 4? Yep, 20 minus 16 is 4. It works. Puzzle solved.
So let's take a quick look back at our new toolkit. Remember, a system of equations is really just a puzzle with a couple of clues and one single answer. You can solve it with substitution, the clever swap, or with elimination, our combine and conquer method. And what's really powerful is that these tools let you turn real-world problems into math that you can actually solve.
So now that you have these tools, now that you know how to find one single answer from two different clues, just think about it for a second. What other puzzles are out there? I mean, things like calculating costs, figuring out mixtures, or even planning a party that are really just systems of equations waiting for you to solve them.